Here we go. Directions for each of these problems will identify the variables x and y. That is actually a pretty crucial part of this, and on the test, which is next time, for this particular standard, you will need to identify those. Create a system of linear equations that you would use to solve each problem. Now, the equations don't have to be exactly like the ones we have, but they should be pretty similar, hopefully.
Wait, what's the standard for this?
Standard 5. All right. Solve the system by graphing using a separate sheet of graph paper. Use one color to graph problem 3 and another color for problem 4. If you guys don't have different colors, that's okay as well. Through all your work and reasoning, write your answer on this sheet of paper for 3 and 4 using a complete sentence. Ah, yes. Again, we get to combine English with some mathematics by writing some sentences. You could write them in Spanish, but I can't read Spanish.
Perfect. And then what do we get? Points?
If it's right.
So you can read Spanish.
All right, in 1982, the U.S. Mint changed the composition of pennies from all copper to zinc with copper coating. Pennies made prior to 1982 weighed 3.1 gram. Pennies made since 82 weigh 2.5 grams. Oh, that makes your pockets literally lighter. All right.
Talk about extra mental abuse.
Thank you. If you have a bag of 1,254 pennies and the bag weighs 3,508.8 grams, how many pennies from each time period are there in the bag? Oh, this is very nice. All right, here's what we're going to do. So we should have two variables, x and a y. And again, we get to decide what these represent. So we've got two types of pennies, right? We got pre-82 and then post-82. So you want x to be pre or post-82? Pre-82. That's what I heard. Isn't there some kind of movie where it's like, back in 82, we would have taken state or something like that? I don't know. Anyways, y will be post-82. You guys know what I'm talking about?
Yeah.
Is that,
Back to the Future.
no, not Back to the Future. What?
What? Mom is right. You could have a salary that pays $25,000
So there's two things on it, these. They told us that there's a number of pennies right here. They didn't tell us which type. So we should get an equation just for the number of pennies, which is what we'll do right here. Pennies is a long word. Pennies. Pennies, there we go. All right, so the number of pennies strictly is just x, which is pre-82. And if I add this to post-82 pennies, then we get 1,254 pennies. Look at these. Well, then we should have another equation based on the weight. I before E, except after G, something like that. Well, X is pre-82, which would be prior. That would be 3.1 grams. So each of these pre-82 pennies weighs 3.1 grams. So I multiply this by the number of those, which gives us the weight of the pre-82s. Now the post-82s weigh 2.5 grams. So if I multiply that by the number of post-82s, that tells us that weight. If I add them together, then I should get this total weight, 3,508.8 grams.
Wait, are we just solving this now?
Well, solving these, there's two ways. The first way that we know of is to graph. The other way is to use guess and test, but that takes a long time. So we need to introduce a third way, which is called sub. What is sub? Well, usually it's a really long sandwich.
Substitute.
With lettuce in between. I like bacon in there too, with some mustard and ketchup and tomatoes
Or somebody who
Don't do this.
and lots of
You're
mayo.
going back to last year when we did this JCWs.
Yes, you can put a hamburger in there too. Why doesn't anyone do that? Make a hamburger sub,
No,
right? A sub with hamburgers.
Oh, they
everyone's
do it in
hamburger.
Pittsburgh.
But you could toast it even, you know
I
what I
mean,
mean?
everyone thinks of eating a sub as a healthy activity, but how do you make a meatball sub from Subway? You take 5 hamburgers, roll them into balls, put them on a bun that holds 5 hamburgers, and you come on.
There we go. Thank you. Now have a seat.
I like to stand up.
Okay. Here's how sub works. So what we got to do is like a sub. You know, you can have stuff in the sandwich, but you can substitute stuff in the sub. Well, that's the way this is going to work. Is we're going to take stuff from one of these and substitute it into the other one. Particularly, see this top equation? Well, we did this for the bell work. We can change this into slope-intercept form, which is great.
Nice.
And if we do, we get y equals negative x plus 1254. Well, now we know what y is, and we're looking for when these two are equals. So, in other words, y is the same for not only the number of pennies, but the weight of the pennies, which means that the y on the weight, right now this is the equation, 3.1x plus 2.5 of y equals 3,508.8 grams, right? But I can see there up at the top that y is x, negative x, plus 1254 up and down. Well, now I've got an equation with just one variable to solve for, and that's great. That's what we wanted. So I got 3.1x, and if I distribute 2.5 into here, I get negative 2.5x, and then this would be plus 2.5 times 1254, 3,135 equals 3,508.8. Bam. Now to solve for x. So let's come back right account. See how the pennies right here in purple, I changed to slope-intercept form in the green right account? Are we good there? All right. All right. I'm going to finish this one. Now when I solve this equation here at the bottom, I'll have x, which is our pre-82 pennies.
2
Equals.
Yeah, I know, right? So let's combine like terms. If I combine the x's, I got 3.1 x's minus 2.5 x's. That's a 0.6 x's.
Why doesn't it go so slow?
Now I still got this plus 3135,
I never got that even as a kid.
and this equals 3508.8. Now I don't want this 0.6x added to anything, so I need to get rid of that 3135 by subtracting 3135 from both sides. Yeah, we can make a decimal right there. All right. So after subtraction, we get 373.8 equals 0.6x. Now to solve for x, which is my pre-82 pennies, I would have divide by 0.6 on both sides.
And then you get...
And I get x equals, so x is 632, which we can write. X, which is pre-82 pennies, 632 pre-82s. Pre-82s. Bam, there's x. So the question now is, how do we solve for y? There's two ways.
Yep.
Kevin, all right.
And why'd you
Let's finish this thing.
And why'd you throw screw lily pads, Mr. Sub?
So right here, we got the number of pennies, x plus a y. That's pre and post 82s. And we're going to take 1254. That was the total number of pennies, 1,254. Let's just subtract out how many pre-82s. So we'll subtract out 623. Not everyone needs to do it like this, but that's a 1,
It's
3, and a 6.
623.
Yeah, that looks a lot better. 623 pre-82s, and then we found right here, there's 631 post-82s. Now here's the problem, though. We got two answers. We got both answers. That's good. The problem is that, well, by this time, like you said, your brain's exploded or imploded, either way. And, well, you're kind of tired and exhausted. But on a test, if that's where you stopped, you may be, I don't know if you guys like it, but you're gambling, okay? If if you come back here to the two equations that we started with,
Oh, we put them together. Huh?
you put x in as our pre-82s, that was 623, and then the y you'll replace with 631, and you just make sure it's a true statement, that's all. Blake has some quarters and dimes. He has 20 coins worth a total of 290. How many of each type of coin does he have? Well, we got two types of coins that we want to figure out. We got X and Y. We'll just say that X is dimes and Y is quarters then. Now, it wouldn't matter if you wanted X to be quarters and Y to be dimes. That's not important. But what is important is that we write these equations properly. So we got 20 coins total. So we'll write an equation for that. I got X, the number of dimes, plus Y, the number of quarters, should give me 20 coins worth. And then we got a total of $2.90. So if I took my dimes, which are worth 10 cents, and then I added my quarters, which are 25 cents, I should get $2.90. So this is a system of equations. We got two equations. We just got to find out where they're equivalent. So what we'll do, again, is change this top equation into slope-intercept form by subtracting x from both sides. So this gives us y equals 20 minus x. Now, yeah, if you wrote it as negative x plus 20, that's okay as well. But in any case, I'm going to go down to the second equation now. 0.10x plus 25 cents times y. But I'm going to replace y with the value we found, which was 20 minus x. And this should equal $2.90. Now we'll solve this one by distributing 0.25 into the parentheses. What do we got? 0.10x plus 0.25 times 20 is 5 minus 0.25x equals $2.90. Now again, we're looking to combine like terms, right? Yeah. So, yes. So I'll combine my like terms right here. This gives me negative 0.15x. And then I still got this plus 5 right here. Equals $2.90. Let's subtract 5 from both sides. And that leaves me with negative 0.15x equals 2.10. Sorry, that's a negative 2.10, by the way. All right, this next part, I'm going to need my calculator because I'm going to need to divide both sides by negative 0.15. Which leaves me with x equals 14. Now this x was 14, so there's 14 dimes. We just got to figure out how many quarters there were. Well, there were 20 total coins. So we can take our 20 coins, subtract the 14 dimes, and we're left with 6 quarters. So all that's left for us is to write this out as a sentence. There are 14 dimes and 6 quarters. Bam, there it is. Please explain.
Okay, so together Ruby and Will run a team relay race, and Will runs twice as far as Ruby. So if Will runs 2, then Ruby has to run 1, and that equals 3. And then if you divide 18 by 3, you get 6. So Ruby runs 6, and Will runs 12. And those equal 18 if you add them together.
Nice.
It would actually be flipped around. It'd be Will equals
Oh, yeah, the other.
Oh.
No,
that's right,
no,
that's
no.
I don't know. I didn't.
Will runs
Never mind, never mind. I thought
Anyways.
Ruby runs twice.
There's one thing we need to fix on this. Just one thing.
One thing.
Labeling.
Labels, miles,
Mine had labels.
and miles.
Oh,
That's it. But yeah, that was very good. So as long as you understand that, I mean, if we looked at the equations on this, by the way, it wouldn't be that bad. X equals, well, what is that? Ruby miles. And then Y would be Will's. Will's is miles. So together, X plus Y, they run 18 miles, right? But we can see that Will is, what was it, twice as much as Ruby. So we would replace Y with 2X. And that's where that 2 plus 1 comes from, right there. Excellent work.
of course not.
All right. Well, Sarah has $400 in her saving account, and she has to pay $15 every month to her parents for her cell phone.
What if she spends?
Darius has $50, and he saves $20 every month from his job walking ducks for his neighbor. Oh, that's nice. At this rate, when will Sarah and Darius have the same amount of monies? How much money will they have? Okay. Not each have, but each have. Okay.
Wait.
2 equations. All right. Okay. Well, we got 2 peoples. We got Sarah. And then we have Darius. Right account. So Sarah, we can define our variables as well, y and x. So what do you guys think? What would y represent up in count? To me, just reading this, at this rate, when will they have the same amount of money? So y, I would say, is the amount of the monies. Amount of monies. And then x. Well, this is how much money they... Let me double check that. X is the number of months. And we can see that because they're saving or spending some amount of money every month. So writing these out, none of these will be in standard form like the last couple were, which is good. Sarah's amount of money will equal, she's got that $400, but then she's going to pay, that's going to be negative $15 every month. Multiply that by the number of months. That is her equation. Darius, he's going to have this much money. Well, he's got $50, and then he's going to save, so he's going to add to that $20 every month. So we'll multiply that by x. Bam. We can see right account that substitution will make this extremely easy because we want to know when Sarah's amount will be equals to Darius. So we'll just replace these equations. Sarah's is 400 minus a 15x. And Darius is 50 plus 20x. And these are equals. So in solving at these, we need to move the x's to one side. Should we add 15x or subtract 20x? And it doesn't matter.
Add 15.
Let's do it. Adding 15x to both sides. And we get 35x's right here. This is equals. We have 400 equals 50 plus this 35x. Now, we got to get rid of that 50, so I would subtract 50 from both sides. Which leaves us with 350 equals 35x. That should be pretty easy to see now. Dividing both sides by 35. We get x, which is Sarah's, no, that's the amount of months, 10. X, the number of months, will be 10 months. They will have equal amount of money. So we just need to solve one of the 2 equations to see how much they will have. We could solve both and just make sure. Let's look. Sarah, which is a y, equals 400 minus 15 times the x, which is 10. So I got y equals 400 minus 150, which means that she would have $250. Well, let's check for Darius. Y equals 50 plus 20 times 10. 10 months.
So much pain.
And we get Y equals 50 plus 200, which is $250. So we can see there and check to make sure that they had the same amount of monies after 10 months, both of which was $250. How much money, when will they have the same amount of money? 10 months. How much money will they have? $250. So all of this is the answer. A farmer saw some chicken and pigs in a field. He counted 30 heads and 84 leks. Determine exactly how many chickens and pigs he saw. There are many different ways to solve this. That's great. And several strategies have been listed below. Solve the problem in many different ways. At least 3 as you can show your strategies below. All right, I don't know if we'll do 3 ways, but let's try 1. All right, well, let's go ahead and write this out. So I can say that X will be the number of chickens and Y will be the number of pigs, because it really doesn't matter. But the heads, each of them has 1 head, so if I took chicken heads and add this to pig heads,
Unless it's a mutant.
then I should get 30 heads. I don't know what kind of farms you visit,
Or maybe.
but I've seen a lot of animals. I don't know about how many 2-headed ones I've seen. All right. Well, if we took chickens and pigs and we looked at the number of legs, there should be 84 legs. But how many legs does chickens have? 2. All right. If you guys want to make mutant chickens, just know that I can do that on the test, okay? Be like, oh, you know what? There was 2 chickens that had 3 legs, so try that on for size. Well, every pig had 4 legs. Okay, what I'm saying is we're not trying to trick you here, okay? It's not a trick question like, oh, there was 8 mutant pigs. Besides, I mean, if they were mutant pigs or chickens, are you guys saying you wouldn't eat them?
Wait, but what if one of them got like
Because according to the law and the FDA regulations, you don't have to disclose that information. So you guys may have eaten them already. All right, in any case, we can solve with these. I can change this one. All right, so that would give us y equals 30 minus x. So again, I'm going to replace y in that second equation with 30 minus x. All right, for this equation,
candy and take a stick and take like a spider web and like just catch flies using. You get that from Shrek?
all right, I'm not really sure what you're saying, but I'm finishing this problem. I distributed that 4, and then I got the rest of this garbage. Thanks for clarifying that. Okay. Anyways,
So what?
I
I'm going to combine this
don't
stuff. All right, I've got these 2 x's and this negative 4 x's,
Trash is like
which is negative 2x, plus the 120. This equals 84, so to solve with these, let us subtract 120 from both sides.
And then there's recycle.
And then we got negative 2x equals negative 36. Divide everywhere by negative 2. And we see that x equals 18. Now x was chickens, so there's 18 of these chickens. Well, if there were 30 total animals and 18 of them were chickens, then there must have been 12 pigs. Alright, for this one, I do want to show another method up in here. And, no, you guys are going to love it. Even though you probably won't. So I can make a table like these, and I thought I saw this on someone's paper. So if I got chickens, and this is pigs, and then I can look at the legs and the heads.
Wait, was it negative 3?
So, for example, if I had 1 chicken, I would have to have 29 pigs, right? So total legs, that would give me 29 times a 4, which would be 121, 16 plus plus the 2.
What?
Let me look at that. Hold on. So that gives me 118 legs. Right there, we know that that's too many. And then we got heads, which was 30. That's okay. So that's all we're basing this off of, heads. So if I had 2 chickens, and then I would have to have 28 pigs. That's good. I got 30 heads. But now I have 116 legs. All right, well, what about if I said that there were 3 chickens? Then I would need 27 pig. Again, that's 30 heads. That's good. But now I have 114 legs. So we would continue this pattern until we got 84 legs, which would be with 18 chickens and 12 pigs. That would give us 30 heads. This one satisfy all of them. In 1982, the U.S. Mint changed the composition of pennies from all copper to zinc with copper coating. Pennies made prior to 82 weighed 3.1 grams. Pennies made since 82 weigh 2.5 grams. If you have a bag of 1,254 pennies and the bag weighs 3,508.8 grams, how many pennies from each time period are there in the bag? Okay. Well, there's 2 things we got, and they are different, so we're going to label these as X and a Y. And when we solve them, we will have the answer for both of them. Particularly, how many pennies from each time period. So, X, we can say, is before 82, 1982. And then Y can be since 1982. Or after 1982, either way. All right, now that we have these, there was 2 critical pieces of information that they gave us. If you have a bag of 1,254 pennies, and then the entire bag weighs 3,508.8 grams. So, we can write an equation just based on the number of pennies. And we know that there were 1,254 pennies. So 1,254 pennies should equal the number of pennies from before 82 and the pennies made after or since 1982 if we add these 2 together. We also need an equation for the weight of all the pennies. And that's an underline, not a divide. So, I've got the pennies from before 82 and the pennies from since 1982. And this should come out to 3,508.8 grams. But we need the weight of the before 82 pennies. And that was 3.1 grams. So if I take 3.1 and multiply it by the number of pennies, that will give me the weight of the pre-82 pennies. Well, if I take 2.5 and multiply it by the pennies, the number of pennies since 82, then I will have that weight. So when I add these together, I should get the total weight, which is 3,508.8 grams. So we've
did it so that their pennies. They wanted to get richer, so they stopped making them heavy and they made them light.
Who's getting rich off of this? All right. How many pennies? Yeah, okay, so we got these 2 equations, and this method that we're going to be using today is very different. This one is based on a sandwich, right? You got a sandwich. Then you got lettuce in the sandwich. Then you got meats. That's the bread color, man. What, you want you want purple bread? You weirdo.
Like an orange bread.
Weirdo. Anyways, this is what we call the sub method. Because we're going to make a sub, okay? So, here's what we're going to have to do on these. We have 2 equations, and just like we did in the bell work, we have 2 equations that we just need to change one of them into slope-intercept form. The bottom one seems like it'd be a huge pain to change to slope-intercept form. So, I'm going to change the number of pennies equation into slope-intercept form. Alright, so let's take these. X plus a Y equals 1254. And if I subtract x from both sides, then I get y equals negative x plus 1254. Now that we have, this is y equals some stuff up in here, particularly negative x plus 1254. So what I'm going to do is I'm going to go to the weight equation, which has a y, and I'm going to sub the value of y into that y. Now that may sound kind of confusing. That's good, because we haven't learned it yet, but that's why we're learning it. So, in this equation, I got 3.1x plus 2.5 of y equals 3508.8. Well, why did I write this the same? Because I'm going to replace the y with the y value that I have right here. And that is negative x plus 1254. Well, this gives me an equation now that has only one variable, one unknown, which I can now solve for using all the strategies for solving equations that we have. So, first thing I will do is distribute this 2.5 into the set of parentheses. So that would be negative 2.5x plus 2.5 times 1254. Alright, so I got 3,135. We still got the rest of this stuff though, which again allows me to solve this equation. So, right now I'm going to be combining like terms 3.1x and negative 2.5x. These combine to give us 0.6x plus 3135 equals 3508.8. Now to solve this equation, I will need to subtract 3135 from both sides. This one looks like this. What's that? Alright, well this zeroes out and the rest of this we can solve. Oh, that should be an 8. That's a 3, 7, borrow from the right account, 3. I got 373.8 equals, this is 0.6x. Now to solve for x, I would divide both sides by 0.6. And I find that x, that gives us 623, and that's x. So we'll come back to this and write the sentence for it. Alright, well that's the number of before 82 pennies. Next we need to solve for after or since 82 pennies.
Still more.
Now we know, yeah, we had two variables, you guys. We got to solve for both of them. That we just solved for one of them. So we can see that there were 1,254 total pennies. We just figured out that there's 623 of the before 82 pennies. So we'll subtract this out, and we got 631 after or since 82 pennies. Now we need to write this as a sentence because it told us to. So let's write this as a sentence. There are 623 pennies that were made before 1982 and 631 made since 1982. That is it. Blake has some quarters and dimes. He has 20 coins worth a total of $2.90. How many of each type of coin does he has? Alright, so once again, we should define our variables x and y. X will be dimes or quarters. Quarters will work. Quarter. And then y will be dimes, or the number of dimes. So we know that the quarters plus the dimes would be 20 coins.
20 coins.
20 coins, right? Then we got to look at their values.
Look at
we
the
got
value.
the quarters, which are worth 25 cents.
Half the quarters.
So if we take 25 cents, multiply it by the number of quarters, then we will have the worth of the quarters.
So this is what math is actually useful.
I love money.
Money's great.
All right, then we've got our dimes.
I mean, the only math I ever have to do when it comes to
Dimes?
money is how much is 10% because tithing, you know.
All right, dimes are 10 cents. If I multiply that by the number of dimes, I will have the worth of the dimes. But if I combine these two worths, which is what I have done, then I should get $2.90. Bam.
It didn't have to give us the value of the quarters and dimes.
Bam, there you go.
I know the answer.
All right, so again, I'm going to change. I got quarters and dimes, x plus y equals 20. I can change that to slope-intercept form. So if I subtract x from both sides, like these, you can write it as y equals 20 minus x if you want. That's okay. So that gave me that equation. Now I have a y that I can replace with an expression. So I got 0.25x plus 0.10 y, but y now is 20 minus x. Now, yeah, if you put negative x plus 20, it's still okay. And this should equal my $2.90. So again, the idea of this is to get one equation that has one variable, which is what we've done. We've replaced y with x values, and now we'll just solve these. So, distribution, you got 0.25x, and I need to distribute my 0.1, so that'd be 0.2 minus 0.1x, and this equals 290. Now I'll combine my like terms, so I got 0.25 minus 0.1x, which would be 0.15x. And then I got plus the 0.2 equals 2.90. So to solve for x, I would subtract 0.2 from both sides. And that gives me 270 right here equals at 0.15x. So this is our equation now, and to solve, we'll just divide both sides by 0.15. And we get x equals, which we love. Those are exciting ones. 18 quarters. Well, if we know there's 18 quarters and there were only 20 total coins,
That means only 2 of them
that
are
means
dimes.
that 2 should be dimes.
What? Oh, magic.
So again, we should check this, right? So we got this. That would satisfy the top equation. X plus y equals 20. 18 plus 2 is 20. That's okay. But let's try the rest of this. So I got 0.25x, which is 18, plus 0.1 y, which is 2. This should equal 290, right? So does this give us a true statement? Let's find out. So 0.25 times 18, that would be 4.5. What the heck? All right, I see where I made my mistake.
Isn't it
It's up in here.
$6 and 14 dimes?
Let's find out.
Because that's what
Up
I
in where? Where's your mistake? Where's your mistake?
Actually, that's a good question. Could anyone see where I made the mistake? And this is the problem because I did it in my head.
Number 2.
Yes, 2, this one right here.
Isn't it like
Well, yeah, number 2, but it's 2. 0.1 times 20 is 2. So yeah, that's good.
That's
This
what I
would
was
be a 2 right here.
So like,
Now when I subtract, I'm subtracting 2, which gives us 0.9 divided by 0.15, which shouldn't be 18 quarters. We should get, not 18. That should be 14 right there, right? 0.9 divided by 0.15. 6 quarters. I got my dimes and quarters mixed up. So 6 quarters, right here. And if there were 6 quarters,
14?
it should be 14 dimes. All right, so the method was good. It just we did a little of the math in there wrong. So that's why we checked, though. So 0.25 times the 6. This would be 1.5 right here. And then 0.1 times now would be 14.
Mm-hmm.
It is 1.4. And when we add these, we do get 2.9. Bam, this one checks off. That is why we check. So we can go back and figure out where we made the mistake. So that ended up being a really good example. Ruby and Will are running a team relay race. Will runs twice as far as Ruby. Together they run 18 miles. How far did each person run? Okay. Well, let's take a gander at these. We'll say that X and Y, these are the distances for Ruby and Will. Yeah, gosh. Okay. Is it that easy?
Yes.
All right, well then I'll try to make it that easy when I explain this, okay? So we got Ruby's plus Will's distance equals 18 miles, right? But we know one thing is that Will has run twice as far as Ruby. So Will is really just 2 times Ruby's, right? So if we add Ruby's, we should get the 18 miles. And if we combine these, we get 3 of Ruby's distances,
Yes, this is what I did.
which is 18 miles. And then we'll divide both sides by 3, and R is 6. Here's the problem, is that R is not 6. It's 6 miles. Now, if Ruby's running 6 miles, and this is another part about this, is that, yeah, some people forget to double it for old Will, or William, or whatever the heck it is. So Will run 12 miles, twice Ruby's length. Now, we should check this, by the way. 6 plus 12 needs to equal 18, and it does. And then the other thing we need to make sure is that Will's is twice Ruby's, which it is. So that would be a good way to confirm on a test that it is correct. All right, so you guys hate that solving with equation stuff, which is pretty normal. My college students hate it as well.
I hate math.
Well, yeah, I mean math in general. I get that. So there's another way to do this. So let's just look. On this one, Sarah has she has $400 rather, but then she spends $15 every month, so per month. On the other hand, we have Darius, who has $50, and then he saves, not spends, $20 per month. So the question is, there's 2 questions on this. When will Sarah and Darius have the same amount of monies? And how much monies will they each have? All right. So yes, I heard someone say that we can make a table. That is correct. Now this is going to be a little bit different than maybe perhaps what you're used to.
Wait, why does it have 3 columns?
Because we have 3 things that we must compare. All right, we have the month. Then we have Sarah's earnings or monies, and then we have Darius' money. Okay.
Oh.
Now let's look. This is after saving or spending, right? So we should consider the 0th month. At 0 months, how much money does Sarah have? $400. What about Darius? $50. Nice. Well, let's go to months then. What about after 1 month? How much does Sarah have? Well, she had $400, yep, and then she took out 15, so now she's got $385. Darius has saved $20, so he has $70. All right, we're going to work our way down in terms of months. 4, 5, 7, 8, 9, and if we need more, we will. So Sarah, let's just focus on Sarah's then. Maybe that may be helpful. Sarah's going to spend $15 every month, so after 2 months, $360, right? 3 months. Yeah, $370, thank you. $355, right? Sorry, I was off by 10 there. And then $340.
And $325.
$325.
$310.
$310.
$295.
$295.
$280.
$280. $265. Right? And then let's see if we can find if Darius is equal to any of those.
90.
All right. So Darius, yep, now he's at 90. 90, then another 20, 110, 130, 150, right?
60.
Did I miss one?
No.
Oh, okay. 190,
190 to
210, 230. So we do need another month. Let's tag it on to our table. And at 10 months, we got 250 for Sarah. And Darius is now at 250. So, answering both the questions, again, I did want it as a sentence. So we'll tag this on. At 10 months, Sarah and Darius will both has $250, was it?
Yeah.
$250. Bam, that's it. Nice. A farmer saw some chicken and some pigs in the field. It counts 300 heads and 84 legs. Determine exactly how many chickens and pigs he saw. There are many different ways to solve this, and you can use whichever method you like. So take a moment and figure this out. That's how we like pigs, right? That's better. Alright, just to help you guys out, the table needs to include a couple things, okay?
4 columns.
Now, it could include 4 columns, it may not. Some of you guys still may include only 3, right?
Yeah.
Now, I would base it off the number of heads because it's easier to tell, okay? And then I would change the number of legs each one. So you're going to have some chickens. And then you're going to have some pigs, right? And then we can look at legs. And this would be total legs. Now let's say that I had, just to start off, let's say that I had 1 chicken. Let's say that I had no chicken. Well, if I had no chickens, then how many pigs would I have? 30. Because there's 30 heads, right? Now, if I had 30 pigs, how many legs would I have? 120, right? Well, how do we get 120 legs?
Times it by 4.
Times it by 4, because pigs, as it turns out, have 4 legs. Those are the wrong kind of pigs.
I have 2 legs.
You're halfway to becoming a pig. See, and this is the purpose of the table is, well, that doesn't work because now we have too many legs. There's only supposed to be 84 legs.
Yeah, and so you go down.
So now, let's say that there's 1 chicken. Then how many pigs would there be?
29.
29, right? Because now I have 30 heads. And if I did these, I'd have 2 legs from the chicken, and then 29 times the 4 legs from each pig, and I get 118 legs. All right, now we're just going to work our way down the table. Let's say I had 2 chickens and 27 pigs. That's 116. You guys should hopefully notice. Yes, dang it, 28. Counting's hard. I haven't watched Sesame Street in a while. This is 3, which would be 27, and now I got 114 legs. That still isn't working, but hopefully you guys know every chicken that I add to this thing, we're taking 2 legs off. Okay? So 4 chickens, 26 pigs, 112. Then you're going to move your way all the way down, and you got to figure out how many of each there is. All right, so we can see, and now some of you guys know how to do this using rate of change, which is good.
You're missing 2.
But we could. Oh, I got them. Okay. No, the 4 right there, the ones that we just did. So let's try to make this 10, right? Account, right? If there were 10 chickens, then there'd have to be 20 pigs. And that would give us 20 plus 20. Well, hold on. 20 plus 80. That's 100. That's 100 legs, so still not enough. Let's just skip up to 15,
Chickens.
which means we'd have 15 pigs.
No.
Yeah, 30 total. 30 total animals.
Oh yeah, sorry. 30.
So that'd be 30 and 60, that's 90, right?
Hey, but are their heads still on their bodies? No.
That depends on if you want me to treat it that way on a test.
It's a slaughterhouse.
Alright, so let's try 16
There's no bodies. There's
and
just heads
14. That didn't work. Let's try 17 and 13. And then 18 and 12. Bam, 84. So that's what we wanted. Let's go and write this out. There are 18 chickens and 12 pigs, and we use the table method on that one. Now, we didn't have to use the table. We could have used the equation, so let's look at that. All right. So for the equations, we could say that x is chickens, and then the y is the pigs. So if we take chickens and pigs and add them together, we should get 30 animals, because there were 30 heads. Now if we take chickens and pigs and we add them with legs, 2 legs per chicken, 4 legs per pig, well, it should be 84 legs. Now this top equation, if I subtract x from both sides, then I get y equals 30 minus x. And now I can replace that y in the other equation. So I got 2x plus 4y, which is 30 minus x. This equals 84. Now to solve this, I would distribute the 4. So I got 120 minus 4x. And then I still got this 2x plus the 120 equals 84. Now combining like terms, the 2x and the negative 4x, give me negative 2x plus 120 equals 84. Then subtract 120 from both sides. And I got negative 2x equals negative 36. Divide both sides by negative 2, and we see that x is 18, which is what we found already. Of course, to find the pigs then, because x is chickens, we got 30 minus the 18, which gives us 12 pigs. So 18 chickens, 12 pigs.
84 legs.